think we're going to get started in about 5 minutes.
Doing that, but I think Met has proven that you can do it for a lot cheaper.
Gotcha. The railings.
Yeah.
Okay. You're going to the.
Okay.
Sure. You want to be on the inside or the outside? Yeah.
Is this where we?
We're a couple rows up, or would you rather be down at the bottom?
No. Okay, fine.
Cool.
You want to sit on the outside? Or you
I'm gonna sit on the inside. I'm not doing it right.
She's afraid of heights. Silly.
Not like a guy.
Well,
More of an anchor.
yeah.
He or she is very tired.
She's afraid of heights. We're still working on that.
There's something about the concrete.
And plus looking over the edge.
Oh, yeah.
We were at a hotel, we were on the 3rd floor and we were on the balcony and she just wouldn't get near it.
Yeah.
It took her almost a month to go up the stairs easily at my house because of those floating stairs.
Okay.
Not that she would be useful for anything at all.
I will one of these days, but not today. I didn't submit anything or anything. Okay. Somebody say I want
There might be another line.
Yeah, it must be another one.
Yeah.
Okay.
You do?
Yeah.
Okay.
Nice to meet you.
Test cases to my web app. The simplest concept. A thing that I should have known after 30 years.
Juan Torres here.
So I watched a few videos and people were adding test cases to test that when an object is created out of the model in general, it has the values. Yeah, you have the model and then you say create object.
That's the real statement.
The name, yeah, keep it I might just have the user, I might just download, like,
Yeah, exactly.
These things should be silently done.
Don't do any mocks. In Django, you mostly just want to do end-to-end tests. Just check if the page have the right, the user's name in the right place.
Yeah, that stuff is, the videos are much better. There's a couple of them that I got. Yeah, it's pretty good.
Oh, okay. Oh.
Man, what day is it?
So what are you trying to sell?
Well, I've been getting.
I don't know if I'm like,
Oh yeah, I'm going the wedding.
So I think that's the next one.
Pure box.
Let me check this Discord.
I want to do that.
If you want to do, yeah, no, it's the same one. They do a PR box too. So I use their PR box all the time. So every PR I win at this point. Let's call it this. 5 Oh, really?
Yeah.
Might be grandfather there. What does he give about? Easy get out or easy get here?
It's just in the marketplace.
It's free though. It's free. Yeah. So I do it on all our public radio. So good. Like
6 chapters.
like yeah, like it's so like normally it's
Yes.
solo dev.
No.
No, you go. You go. You're on time. Are you okay going first?
Yeah, sure.
That's probably still 15 minutes.
Okay, sure. I'm just gonna put my track ways for myself.
Okay.
Yeah.
Okay.
I can put it on the side.
Sure. Whatever you want. We can record it. But,
Yeah, I'll do it from my
go ahead. Why don't you set up?
Yeah, sure. I'll do it right now.
Yeah. Okay. That's okay. I think I'm just gonna get started with intros. We'll just do it. All right. Oh, I should switch the screen.
Invite all your friends.
But how do I get to the website?
All just.
I know it's a very difficult thing to learn.
Yeah.
All right. We're gonna get started here. So if you're here for San Diego Python, you're in the right place. If you're here for something else, wrong place. I'm David. I'm one of the organizers. I do want to thank Jeremy, my other organizer. He helps wrangle all the speakers so we have good talks. So that's awesome. I do want to thank Qualcomm for having us here, and specifically Drew and Urivan and the engineering development team, which is the team that kind of like helps Qualcomm employees keep their skills current. So they're the ones kind of letting us use this venue. So that's awesome. I also want to thank Neo4j for providing the food for the meetup. So they're the ones who got the pizza. Neo4j provides a graph database that for certain types of operations can be orders of magnitude faster than a traditional relational database. You can download it and run it yourself, or you can get a managed version in the cloud of your choice. There's also a giveaway, which you have to scan a QR code. I think I put an actual physical paper that you can scan on the door, but we'll also put it up between one of the talks at the meetup. So I think they give away a drone. It's not just to San Diego Python, it's across all the meetups they sponsor, but you can win a drone if you're a drone enthusiast. Cool. A couple other small announcements. We have a Saturday meetup for San Diego Python. It's different from this one. It is not in person, so it's 10 a.m. on Saturdays. It's online. Check the meetup page. You can get onto our Discord. It takes place on Discord. You can get to there from our website, sandiegopython.org. So if you go to the website, basically all the links to all the stuff is there. You can get to these meetups that are recorded. It has our next upcoming meetups. It has how to get on Discord, which is the Saturday group. The Saturday group's on Discord. It has everything that you would want about San Diego Python. So it also has a code of conduct. Yeah. And if you're interested in getting involved in the site, it is up on GitHub itself. And there are people on Discord happy to guide you with contributing to the website. Mostly me, but other people as well. I think I talked about the YouTube channel. We record the meetups. They appear on our YouTube channel, which is youtube.com/@SanDiegoPython. They're streamed live in case you ever miss one. And then I do also want to mention we have upcoming weird schedules for November and December because the fourth Thursday of the month in those months are holidays. You're like too close to holidays if they are not actual holidays. So we will be on the third Thursday in November and December, and then back to the usual fourth Thursday schedule in January. So do not show up here on Thanksgiving. You will be alone. Have turkey or something else with your family or something. All right. Couple upcoming conferences. I like to just kind of like mention conferences that are coming up that are Python conferences. PyData NYC is coming up. It's November 6th to 8th. I think that one's in person in New York, but they have a PyData Global, which is in December. I don't know the exact dates on that one. That one is virtual. So if you're in New York, you can go to the NYC PyData, but if you're not going to New York, then you could do the global one. There's also a PyLadies conference. It's December 6th to 8th. This one is virtual as well, and it's conference.pyladies.com. And I don't think there's been like a true PyLadies conference like this in a little bit, so this is going to be awesome. And lastly, and this is like the most important announcement of all the announcements, you too can become a speaker at San Diego Python. I'm highly motivated to find speakers because Jeremy and myself are kind of the speakers of last resort if we don't get enough speakers. So San Diego Python is run on speakers. You only have to put together a 5 to 7 minute talk. You don't have to talk long. We have a 100% survival rate for speakers. Nobody has died. And your talk, all skill levels are welcome. So like, you know, we have people talking about AI stuff. We have people talking about advanced NumPy stuff. We have people talking about the trouble they ran into when they set up their development environment. All the things in between there too. So like, don't think you don't have enough knowledge to give a talk. You can do it. And you can sign up for a talk on the website, sandiegopython.org. There's a link on there and you can give a talk. I should make the link really big. It's the most important thing on the website. Cool. Lastly, JFrog is our other sponsor. They are a DevOps platform for continuous releases. For example, if you need to host a PyPI inside your company firewall, that is what their product does. Very cool. And I think that's me. And without further ado, we'll get into our first speaker, which is Juan Torres. Juan is going to talk to us about data web applications using Python on the concentration of banking and the usage of AI tools. So Juan, I'm going to let you take it away, and I will help you get the HDMI set up in case things go horribly wrong, which they will not.
For sure. Is the Wi-Fi the Qualcomm desk one?
It's Qualcomm Hall, and it is open. It should be wide open, like no authentication required. The other one requires authentication and is kind of.
Gotcha.
Yeah.
1, 2, 3.
And then you want this thing. Oh, you got it. And
Yep.
it's showing up. Oh, that's.
It's the CL5Q
No.
Hall.
No. It should be Qualcomm Hall. That one.
Qualcomm Hall. Okay, gotcha. I think I got it.
And then I will get you set up. Do you have audio coming out of the?
1, 2, 3.
HDMI?
1, 2, 3. That's okay. Look at that. So, cool. Let's see if this is working. 1, 2, 3. It is. Hi everyone, my name is Juan, and today what I wanted to present with you is my application on the concentration of banking. So, give me a second, let me just bring up. All right, cool. So one of the things that I wanted to do with this application was to quantify the concentration of banking as a phenomena, as a process in the economy. And what I mean by the concentration of banking is simply the tendency of capital centralizing more and more around financial institutions that create a financial network that essentially dominates commerce, investment, trade, production in the US economy. So one of my inspirations for this was actually reading the work of B.I. Lenin, Imperialism, the Highest Stage of Capitalism. And in his work, he talks about banking's accumulating more power over time, particularly in the United States and Germany during the early 20th century. So I put up on the task to find out if this is the case in the US. So the way I went about trying to quantify the concentration of banking was to look specifically at 4 banks in the US, the biggest ones: Chase, Bank of America, Wells Fargo, and Citibank. And what I wanted to do is to look at two specific properties of the process of concentration of banking. One being the activities of acquisitions and mergers of those big four banks. And then secondly, the share of consolidated assets among all the large commercial banks in the US. So let me show you the application. So right here, you can see a network plot. And each data point is essentially an activity according to the Federal Reserve. And what an activity is nothing more than a merger or an acquisition carried out by the bank. In this case, it's Chase. So if we go all the way to the most recent activity, we can see that Chase acquired First Republic Bank in the year of 2023, and it has a note indicating First Republic Bank failed and ceased to exist, blah, 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 blah. And we can go forward with filtering based whether it was an acquisition, whether it was a merger, whether the activity was as a result of a failure, split, charter discontinue, and we can include subsidiary consolidations as well. And we can see the same for Bank of America, Wells Fargo, and Citibank. And on top of this, I summarize this information in a phylogenetic tree map that essentially gets us the information on the activities of the last 2 decades, the most important ones. So we see in the phylogenetic tree map, we have Wells Fargo. We're gonna see that back in 2008, Wachovia Bank was acquired by Wells Fargo at a price of $14.8 billion. On top of this, my application has a bot that updates stock historical share prices of the big four. So we're gonna go to the most recent data point. We're gonna see that it has actually, as of today, a price for JP Morgan Chase as of October 24, 2024. So now I wanna look at the second property that tries to quantify the process, the activity, the phenomena, the change of the concentration of banking. And it's gonna be on the consolidated assets of large commercial banks. The Federal Reserve qualifies large commercial banks as those banks that essentially have $300 million in consolidated assets or more in order to consider them large, quote unquote. So we can see here a linear regression model that essentially tells us that the big four accumulate $20 billion on a quarterly basis. That will be $84 billion on a yearly basis. And then we have a tree map that essentially tells us the market share of the big four compared to all the other large commercial banks. So right here we can see that large commercial banks essentially control 57% of all consolidated assets. That means that just the big four essentially control 43% of all large commercial, of all the consolidated assets out there, with Chase essentially controlling about 16%. And then right here, what we have is essentially a pie race chart that details the race of the market of consolidated assets by the big four banks compared to all the other large commercial banks. And this chart right here is a representation of what's going on the left and the linear graph. So we have the red line here being the big four banks, and it's telling us its percentage of control on the consolidated assets compared to the total assets. that's a little dramatic. Cool. So this is one of the applications that I use, right? And so for the consolidated assets here, we essentially, what I did was to go to the Federal Reserve. I web scrape this part right here, each link. Each of the information is already in a tabular format, but as you can see, it's not downloadable. What I can do is only look at the HTML code, and that's what I did. My automated data pipeline essentially takes this data, concatenates it, cleans it, and then puts it into a pandas data frame for us to be able to see these data visualizations right here.
Did you use read HTML for that?
What was that?
Did you use .read HTML? How did you read that HTML?
I think I did. It sounds really similar. The creation of the data pipeline was a couple months ago. So if I recall, out the automation of uploading the information into CVS files for then to be for this app to have its populated graphs with the most recent information on a quarterly basis. So yeah. So this is the first application that I wanted to show you, right? The second one is the AI banking assets data application. So this is, in a way, a continuation of the first one, but now we're not limiting ourselves to just the Big Four. We're looking at all the data that was collected from all the quarters, and we organize it in a tabular format so that we can filter it based on consolidated assets if we just want to have the ones that have trillion worth of $1 trillion or more. So if we do that, we only get the Big Four. Or if we want to include $500 billion and above, we're just gonna get, what, 10 of them, right? So ipso facto, just by the fact that we're moving this filter, we're demonstrating that there has been so much accumulation of wealth that even basically modulating this by a couple of percentage of a trillion, we only get a few bags. But if we basically increase it to the bottom, we can see that we can move all the way to 215 pages. So we can also filter based on a bank name. So if we want to analyze JP Morgan Chase, we can do this. And we have the information right here, and we can download this information in a CVS file so that your research analyst can look at it, do its own research. And then the most exciting component for me is the integration of AI analysis tools. So for this one, we have an agentic system that has the task of visualizing the data that we see in a tabular format into a Plotly plot. So let me show you. Let's see, create an insightful line plot on JP Morgan. So what it's going to give us is the data visualization, and then it's going to give us the code that it was used in order to generate the plot that we're going to see.
How did you connect it to your data?
So for the AI agent to be able to recognize this tabular format, it has to be vectorized into a string, right? So there's a little bit of there are limitations to how much input it can take, right? But essentially, we're using OpenAI for it to get the string of data, and we're telling it to transform the string into a dictionary that it can then use to create the data visualization. So let me show you. So right here, we can see the plot that it was able to generate. A line plot taking the last 10 quarters of JP Morgan Chase. And this is the dictionary that it used, right? So it uses the variable data in order to store the dictionary. And then it uses that variable to visualize the data.
Did you do a query on your database to retrieve that JSON or dictionary?
The query is limited by the filters. So if we were to actually get rid of these filters,
So it's reading your page right there. It's reading data right there from your page, basically.
yeah, essentially, if we were just to give it this information right here, and then, so it gives us this information, and we just take JP Morgan Chase, create a insightful plot, then it will take this information right here, and then create another graph. So it's working right now. So it's dependent on the prompt that you give it, but it's also dependent on the filtering of the information that you see in the tabular format. It's both. And so now I decided to do a bar chart because it has different information. And we're not specifying it to create a line. And instead, it's taking the liberty to decide what is the best method to represent the data that we see right here. And according to its discretion, it decided to create a bar chart. So yeah, and then this is the code. Again, a dictionary, then visualizing it, and then I did instruct it a specific theme to match with the whole theme of the thing. Like if you can see right here, Plotly Dark is used right here because that is one of the things that I did integrated into the prompt engineering of the AI agents. So there's a lot of like prompt engineering work that has to be done here in order to decrease the probability of having a mismatch in aesthetics and having a mismatch in just the variability of how the AI agent decides to carry out and solve the issue that you put it into.
Is all your code on GitHub or something?
Yes, and I will give you the QR code for you to access my repository. So this is one tool, right? The second tool that I was able to generate, that I was able to create for this particular tool is basically an agentic system. So now instead of using just one AI agent, is using two of them. So let me show you. So let's pick, let's say, Wells Fargo, and let's press analyze. So what it's gonna do, this tool is going to carry a news analysis on a particular bank of choice. So in reality, we can input PNC, we can put US Bank, right? But for, since this is still like something that I'm working on, I just decided to put 4 banks. And then it's gonna have a senior research AI agent analyst that is gonna carry the news search. And then what it's gonna do, it's gonna give it to a strategic banking content writer who is gonna then grab that information and then make it more general public friendly for people to be able to read it. So if you see right here, it has a key takeaway section. And it says, Wells Fargo announced it might incur a loss of $2.3 billion on its commercial real estate official loan portfolio. The potential loss highlights the challenging phase in the commercial real estate sector, which could impact the bank's financial performance negatively. And then if you go down here, it's gonna give us a more detailed analysis on all the topics that we see in the highlights. And then it's gonna give us the sources that it got its information from. So if we go here, it's gonna take us to Money US News Banks. And and basically this is one of the articles that it used as of October 24, 2024. So yeah, this is the 2 data applications that I developed that centralize that around the topic of banking, its concentration, using AI in order to automate the process of data visualization and news analysis. And if you would like to search, let me see, be able to utilize this, the applications, there's the concentration of banking data app, then we'll have the AI banking assets data app, and then if you want to access the GitHub repository, there's the QR code, and then if you like to connect and stay updated with future projects, you can connect through LinkedIn.
We have a question from chat.
For sure.
Does the Plotly AI always embed the data in the code, it has the data in the code snippet instead of, or rather, does it have the data in the code snippet instead of reading the whole data? For large data sets, would that be problematic?
That's a really great question. So that's one of the first challenges that I was facing with the utilization of an AI system, of the fact that essentially it's an issue of scalability, essentially. Because theoretically speaking, you can feed it the whole data. But for the purposes of this application, I did have to limit the amount of data to the top 10 rows. So it doesn't take the whole data. If I were to give it the whole data, then it will have issues of being overwhelmed with too much information. And at the same time, it will take really long for this data visualization to be processed by the AI agent that I created. So, and that's one of the things that I actually have been thinking about how to go around, because I do actually want to have an AI agent and an agentic system that is able to intake all the data necessary to carry a comprehensive analysis. So that is a really good question, because that's the main issue that I'm facing right now. No, hold on. He went first.
What was the main framework for your little website tool?
Dash Plotly.
I know the Plotly, but the overall frame where you have your for your data analysis. Go back a couple of steps.
Sure.
Yeah. So that display that you have there, what is the tool you were using to create this?
It's in order to create the web application, I did use Plotly's Dash packages. So this is you know Plotly, right?
I know Plotly, but I just use it for plotting.
Exactly. So Plotly is not limited to data visualizations. It's actually quite an intricate system in order to create web applications just like this. So this is the reason that I actually used it. Its only limitation is that it's not the best tool for people to use it on the phone. So if you actually use the QR code, you're gonna see that it has a lot of like aesthetic deficiencies in how you can utilize it in your own phone. So, but other than that, basically, if I were to, I mean, I don't know if I have enough time to go to the code, but it has really complex and intricate ways to filter information, to manipulate it, that I feel really fulfill the task of measuring the concentration of banking, the main research question per se.
So when you say you had a text going in, was it just like a CSV, or was it a text as HTML, or what was that text?
What do you mean by text? You mean the data?
Before it creates a dictionary, you said you sent it some text.
You mean the string?
The string.
Yeah. So correct. So essentially, what I instruct my application to do is to take the top 10 rows of my data, and what it does, it converts those data points into a string.
Like a JSON string or
Um,
a CSV, or what was your serializer for HTML, an HTML table?
No, I mean it's so basically what it does is this. It takes it in, it puts it into quotes.
Oh, really?
Yeah.
It's just the HTML.
Yeah. So it takes it into quotes, uses those quotes to then feed it into the AI agent, because the whole process of being able to utilize AI is based on vectorizing data, right? And I mean, my knowledge is really limited on vectorization and using vectorized databases. But the means through which I was able to, quote unquote, vectorize my data was through the utilization of strings around this data. And for these data applications, this is like the modus operandi of how most people use how most people like feed data to LLMs, large language models. I'm sure that there's more complex, there's more sophisticated ways, right? For the particular purposes, it worked well.
So you put quotes around whatever you had there and just fit it in?
In a way, but I don't do it automatically. I don't do it manually, right? The AI agent does it by itself, right? So based on what the function tells it that there is, so basically there's a function that filters out the information that you see here. As you were able to see, I was able to filter based on just one bank. And so the function then creates a variable that, let's say it's a pandas data frame. It has to convert it into a string to then feed it to the AI model.
So then you use pandas, underscore, what is it, repr or something in order to
Ripper.
Did you use Python?
Oh yeah. All of this is Python based.
There's a repr thing that will create, you know, the equivalent of a Python data frame, which is, you know, Python stuff. It'll give us a list of, I'm not sure exactly what it is. I think it's a dictionary of lists where each dictionary is a column header and each list is a column. I think that's what it produces.
Yeah.
Did use that in repr. Yeah, maybe we can see.
Yeah, I want to try. So this is one of the prompt instructions, right? Because I have to prompt engineer the AI model. This is for you're a data visualization expert.
What object type is in that data variable?
Object type?
Yeah, that data variable, what object type is it? Is it a data frame?
That is a, at one point it is a data frame.
But line 409, you have data and curly braces right there.
What is it right before there then?
Oh yeah, data right here, right?
Yeah.
So
Go up, let's see what it is. We'll figure it out.
Yeah.
Putting them on the
Go up
spot.
a little bit, I wanna see what data it is.
no, it's fair. So data, boom, boom, boom.
There it is. It's probably a data frame.
Yeah, that's what I said. It's a data frame.
Converted to a dictionary.
Yeah. So it's essentially,
That's what that is like, records where each one is a dictionary.
It's a dictionary of dictionaries. That's how Pandas does that conversion.
yeah.
Each column is a key.
I think it's records, it's rows. Pretty sure.
So it's a data frame before it gets converted into a dictionary.
You're right.
Yeah.
Okay, so you have essentially a list of dictionaries. Each dictionary is one row. Yeah, okay, so I understand.
Yeah.
Very good. So that's what that is.
Yeah.
And cool. I'm amazed that let's go back to that prompt because I'm very interested in how
Sure.
you actually set that up. And I think you pass it up a while back.
In the 400s. Okay. There we go.
Oh yeah.
So, okay, you're a data visualization expert and use your favorite graphing library, Plotly, only. Pick a dark theme for the Plotly visualization and the code with the background color of, and I actually specify the type of color, text color. And then the data is provided in a string representation of the first 10 rows of the CSV file. Notice here that I had to specify the 10 rows, because if I give it more rows, then there is the issue of taking too long and overwhelming the AI agent with too much information. And here's the data, which was a data frame, and then convert it into a dictionary. And then I give it instructions. Convert the string data into a dictionary with appropriate keys and values. And as you saw on the code of my data application, it was indeed converted into a string through the variable data. And then create a pandas data frame from the dictionary, use the data frame to create a Plotly visualization as requested. And then I tell them to use the fig variable in order to represent the figure. Do not opt for direct string parsing approach to create the data frame and instead use a dictionary-based approach. Notice in this line right here, on point number 5, that essentially I had to put restrictions on the AI agent. And why do I have to do that? Because the AI agent has variability in the way it tries to solve a particular issue. So in order to contain that variability and get the correct outcome, you actually have to put restraints on the AI agent on what to do and then not what to do. And so this is one of the most important keys here, because I was struggling profusely and intensively to get the AI agent to actually visualize the data and decrease the rate of error from 90% to now maybe 0% or 0.01%. So in your code, convert the date column into a datetime object. This is another thing. The data is not, since now it's a string, whatever format I had it in my data frame, it's erased. So now I had to re-specify how I want the AI agent to specify each column, what kind of data type I wanted to be as in order to get the outcome that I want. And then 7, order the dates in the data frame in chronological order. You'll be surprised, the AI system actually doesn't organize them in a chronological order. You will think like logistically, like someone would do so, but it doesn't. Always include all necessary imports in your code. Follow the user's indications when creating the graph. And then I had to actually create further instructions here, give an example of how I like it to create a dictionary. So as you can see right here, I created the variable data processing example to give it an example on how to carry out the creation of a dictionary. So there is a lot of the work in dealing with AI agents and agentic systems goes along the process of being able to calibrate yourself around prompt engineering. Because the AI agent is gonna have a lot of variability. It's gonna try to do things in its own ways, in different forms. So this is why one of the most important skills that I was able to harness with this project is prompt engineering.
That example you gave, it's going to try to generate Python code. So you get a Python code response from the LLM.
Yeah.
Then how do you run it on your back end of your web server to generate the plot?
Back end of the web server.
Is this? Did you do an eval on the response from the LLM? How did you run that Python code that it replied with?
Or does it give you the plot straight out?
It gives me the plot straight out.
You told it to give you Python code. I mean, that example there is Python code, right?
Yeah.
And so it's not replying with Python code. It's replying with something that doesn't look like what you gave it as an example.
It's not replying with Python code.
Did it reply with something that looks like that example or not?
Yeah, it did. As you can see right here, it is using a dictionary.
Okay, so that code was not the code that created the plot. It also replied with the code and the plot.
It is the I mean, the.
Have you run that code? Have you copied and pasted that?
Oh, how do I run that code? Yes. So there is. I gotta recall where this is at.
There's no guarantee that it is going to produce the same plot.
Well, no.
You capture the response and then run it yourself?
Yes. So this.
Did you capture that and then run it?
This you can copy and paste it in a Jupyter notebook, and it will give you the same results.
Got it. Cool.
Yeah. So copy and paste it. It basically imports everything. You put it into a Jupyter notebook. Will give you the same visualization.
Nice.
Yeah.
But the Plotly thing, Plotly Dash provides that sort of facility as well?
Yeah, well, I mean, to say that Plotly does it, is giving them a lot of credit. I mean, Python itself as a language has the flexibility to do so. in that web application data frame or another one. So I wouldn't attribute it to dash plotly, but the dash plotly is very dynamical. And that's why I really like using it, except for the deficiency of the user interface in the cell phone. Cool. Any other questions?
Which model did you
Good question.
visualize to do the data visualization?
For both the data visualization and the agentic system news analysis, I use ChatGPT 4.0. I was trying to use Mistral, but it had a lot of errors. So far, I found that ChatGPT 4.0 is one of the most potent tools in order to decrease margin of error in my
For the
results.
news analysis summarizer, have you thought about using Gemini because of the token size on that is a lot larger?
Yeah,
And then also the Notebook LM feature that Gemini has is really good for bringing information to more human layman terms.
yeah. I have not thought about it, but maybe I should check it out. That's a very good point. Cool. Any other questions? Great. Cool. Thank you very much.
Thank you. That was very interactive.
Yeah.
Lots of people had questions.
I know.
We have a quick audible here in that we have to swap a speaker, and Jeremy is going to be our next speaker. Jeremy's going to give us a heart-to-heart. It's about time. So, yeah, yeah. Are you going to do the giveaway thing first or second? Second. Okay. I'll let you set up then. Do you have audio coming out of your laptop or no?
No, not for this. Alrighty, so. Let's see, there's something I've been wanting to get off my chest for a while now, and it's about time. Let's see.
Your voice is cutting out.
Oh, okay. Let's see, there's something I've been wanting to tell the entire community for a while now. Just get this off my chest. And it's about time. It's about daytime specifically. Let's start with some easy things like from datetime, import datetime. If you're going to make a module, make sure the module name is not going to be the same name as your main functionality. I'm sure you've got caught in this trap as well. Let's see. Work with this long enough. It's okay. Let's see. We'll go past it. So, datetime.now is an easy way to be able to get, let's see, what time it is now. And what that does is it produces an object. Let's see, it stores it locally in year, month, day, hour, minute, second, nanoseconds. That bears repeating. Year, month, day, hour, minute, second, nanoseconds.
That's microseconds.
Micro?
Your microseconds.
Oh, microseconds?
6 digits, not
6 digits, not 9. Oh, sorry. That's right. Don't usually use that part. But let's see. The year, month, day is what I wanted to focus on. Lots of people like to reorder these things around. It goes from biggest to smallest. So, how many of you used the, let's see, now if you want to be able to turn this into a string value, there's this wonderful feature called ISO format. And I want to talk about what this was, but how many of you used ISO format before? 1, 2, 3. Yeah. Large show of hands. So this automatically turns it into an ISO formatted string. What is ISO formatted? ISO is International Standards Organization. If you want to look up this particular piece of information, it's ISO 8601. Let's see, it spells out what should be, let's see, there's a couple of different types of date time formats. And so you can use these for any kind of a calendaring system. Let's see, maybe it's every month, every week. Maybe it's, let's see, you want to just specify the date and not the time, or the time and not the date. So it's got features in for all of this. The Wikipedia page is great. I would highly suggest taking a look at that. So that's ISO format. Let's see. So I'm just going to save this and just call this was now. And so that's my string. Now I can take a datetime dot from ISO format and take my was now and be able to get that back to a datetime object. So it goes both ways. You can go from a string to a string. Let's say from a datetime to a datetime. So it's got that nice bookends kind of feel to it. All right, so
Robust if you like erase one of the nanoseconds and microseconds.
Yeah.
Is it pretty robust to making changes or
Yes.
eliminating some of them?
Let's see. The question is, it was.
Get up there on the ISO format. Yeah.
Let's see. Let's change was now. So was now is currently this. Let's.
Slice it to the last 3 characters or something.
Okay. Let's see. All right. So this is what we're changing it to.
Nice.
Was now is equal to that, and now datetime ISO format using our new was now.
Nice.
It's able to deal with a lot of situations like this. So, highly suggest, highly recommend. Okay, so datetime dot strp or strp, there it is, strip time. How many of you have used this one? A couple of people in the room? Under duress. That sounds about right. So what this will do is this particular function will take any type of format specified any way, just about. To do anything with this, I always go to strifttime.org, and let's see, I have to look this up every single time on how to deal with this. Let's see, this week I was dealing with the database conversion having to do with date times, and I lost time. How ironic. Let's see, on dealing with date times. So this is the way to deal with, let's see, all sorts of date times that are presented outside of the normal ISO format. ISO 8601. Remember that number. Anyway. All right, so how many of you use strift time? Okay, lock the doors. This is an intervention. This is no longer a talk. Okay, for those of you who have decided, let's see, you're going to make it difficult to be able to, let's see, transact with systems, be able to pass dates and times across. You're going to make people go to this website and look up all of this stuff in order to be able to, let's see, get dates and times across to other systems. Let's see, please stop doing that. Let's see, anyway, that's it. Let's see, this is our normal lightning talk time. We try to keep it under 7 minutes, but let's see, we're going to, let's see, I'm going to stop there. Anyway, if anybody wants to be able to give a lightning talk, let me know. We're always looking for the next speaker. So, wonderful.
So
Yes. Oh, good question.
The ISO format was really convenient if I had like a text, spot in a cell or something, or text file I needed to put it in, like say in a pandas data frame or something. I don't want to put that in. That was a convenient string format. That would be easy to convert back and forth. Because the hardest thing about these is time zones, I think.
Yes.
Once you get into time zones and you start to, also if you're trying to compare times and say the server is a different time zone, you have to then try to figure out what time zone it's in and compare stuff like this. Very difficult. Time
Yep.
is very difficult.
Yep.
I don't like this thing either, so I agree with you on that.
Let's see. Yeah, time zones is, let's see, it's one of those, we don't talk about time zones in daytime types of scenarios. So.
And also the leap years and so forth, of knowing when the daylight savings time starts and stops.
It has all those stages as attributes.
So PyTZ is a great module that's kind of an add-in. It feels like it's kind of shoehorned in, I'll say, but it has its own necessary functionality. Yes?
With regards to time zones, is it best to store it in the date time? Like when you're storing the data in a database, should you keep the time zone data separate from the time, or should you keep the two merged together?
I would store it in something called UTC and then specify the local time somewhere else.
Okay.
Proper databases
You can
store
do that
date
offset
times with
stuff
time
in there.
zones.
You can do the offset from UTC, but they'll deal with it in the package if you want to do that.
Yeah, I've usually just stored it as UTC to not deal with time zones and present it UTC, but
It gets you in trouble.
Yeah.
Django has a massive amount of documentation on how to avoid all the trouble factors you want to.
A lot of this trouble with databases, Postgres stores date times with time zones. Some other databases do not. If you do that, you will not have problems. Store the time zone with the date time. It's true with it. Okay.
Yeah, absolutely.
The suggestion was make sure to store times with, or the time zones with the date time, and Postgres has this particular functionality. So.
And you don't want them presenting them UTC time. You don't miss their appointments.
Should we do the giveaway? Or?
Yeah, let's do that.
We do have a giveaway. I think I promised you that we would put it up on the screen. Do you want to just pull it up?
Either way.
Yeah, I think it's
I didn't
in
have
the
it.
Discord. And this is basically Neo4j has a drone giveaway. Neo4j is our sponsor who sponsored the pizza. And so if you want to scan the QR code, there's also, I think, a copy on the door. But if you want to scan it, you can win a drone if drones are your thing. So awesome. Yeah, that's pretty much it.
Okay.
I figure we'll just leave it up on here for like 30 seconds. And then we'll get to our next speaker, who is Ray. Ray Lutz is going to talk to us about optimizing conversion of JSON. Oh, sorry.
Go ahead if you want to go first.
You're all
Wait.
set?
You said it's David Ward. Am I on that list?
Wait. No, sorry. You're not on this list. Ray, you're on this
Oh,
list.
okay.
Dude, I'm confused.
You're in for next month.
You're next month.
Oh, on next month.
There's a different David on my list.
Oh.
Who's our last speaker. Sorry.
Jeremy said,
I
yeah,
was
you're
confused.
going.
I was
I
confused.
specifically asked Jeremy.
Yeah.
Sorry, I was
No.
confused. Ray, you're up.
Oh, okay.
Okay. I think we're good here.
All right.
Ray, you can, yeah. Do you have HDMI? And
Yeah.
Do you have audio coming out of the laptop? Okay. And then what you see there is the same as what's up here.
Okay.
So whatever. Yeah. Okay.
I was saying, oh,
Sorry about that.
Give me just a minute to locate what I was working on.
no, that's what I said. Oh, I know you did. Yeah. Yeah, but I guess you didn't understand that. Okay.
Okay, well, my name is Ray Lutz. I'm with Citizens Oversight, Cognisys also. I have been working on a basically election integrity project, which does an audits of elections using the ballot images. Some of the data comes in as JSON, and it's a structured JSON, and this is not here in the right place, so maybe I'll just sort of show you this structure here, which is my version of it.
So if you can imagine this being JSON, but this is not what the words are these are not what the titles are in it. But it is a contest, and then you have some attributes, and then you have some votes, and you have different options. So it's a nested JSON. It's not JSON, which is, say, field name, data, field name, data, field name, data, field name, data. Next line, same thing. So I had about 350 files, and most of them were pretty small, but one of them had 9,000 records in it, which doesn't sound like much. But for some reason, my function was taking 54 minutes. And most of the time it was very fast. So I'm going, what is going on with this parsing of this JSON file? Bunch of files, actually. And so let me see down here. I can maybe show you the function. Maybe not, because I didn't actually get it queued up very well. But the bottom line was, after I got all done, I'll tell you what was going on. I had the function reading in these things, and then start undoing it and creating records. And then at the bottom, the cleanup, where I do some analysis of the whole thing. It was indented one too far. So in other words, the cleanup was being done for every record, making it take a very long time. But I didn't know that. And looking at a Python function that's sort of long, I didn't notice that at the bottom down here, it was indented one time too far. And so therefore was doing those calculations for every record. That was when I finally figured it out. Now, at 2020 hindsight, what I should have done was look more carefully at exactly what the problem was by timing what was there, which is eventually what I did. So I eventually got put timing in between all of my things, and then I figured out, oh, the real problem was that the indentation was wrong. I couldn't see that because it's easy to miss. So what did I look into? Well, ChatGPT recommended maybe I should use DuckDB because it has the ability to not only open up the zip files, the zip file that has all of these JSON files in it, automatically open the zip file, process them in, and load it into the database. I go, that's wonderful, we'll do that. No, actually, ChatGPT was wrong. It doesn't open the zip file for you. Okay, so I'll open it up myself. I extract everything from the zip file and then read it. No, it doesn't do that either because it doesn't understand the nested JSON. You have to have a very simplistic JSON for DuckDB to understand. But in the process of looking into DuckDB, I found out that it was using this really good JSON parser called OR.JSON. So OR.JSON is super duper fast, and probably that would be a good thing to show because why not look at a website and we'll look at OR.JSON and find that because they have some timing here, I believe, comparing it with other, here we go. So here is OR.JSON versus OR.JSON. So you can see you get a 1 if you do it itself. UJSON is slower, rapid JSON, simple JSON, and just the JSON from Python 17 times slower. So I thought, well, that's good to know about this OR.JSON just right there, because so in the process I learned that DuckDB doesn't do the JSON stuff that I wanted, but I did learn that OR.JSON is a super fast JSON parser, so I'm using that now. You have to add a bunch of stuff to say, if you're using, let me pull up my thing that I have to add to that. So if we find here, oops. And we'll find where it is. Okay, so if we, I'm gonna find it again. So you have to add this thing here, which is a types handler. If you want to do it and have it be fairly successful, you have to say that if it's a NumPy float 64 or float 62, then you turn it into a float. If it's an NumPy integers and bools and so forth. So you've got to have this thing to work around the issues that it has converting. But or JSON will do a few things that regular JSON won't do, such as have integer keys of the JSON of a dictionary. Normal JSON, you have to have strings. You can't do an integer as a key. So then I have my functions here where the wrappers around any kind of JSON I'm using, and it's to encode it or decode it. And so now I'm using or JSON. So that was a good thing. So the fact that I didn't do it the right way meant that I tried to use DuckDB, and in the process learned about or JSON, which was a success story. Now I have a really fast JSON parser. And then the other thing was I learned that there are some other databases that do it. Such as, SQLite has some JSON functionality, and also if you're using, can't think of it now, but it's very popular, kind of like MySQL, but it's the other one. What's the more popular one? That one. It has some really good JSON handling. So the idea was bring the JSON in, put it into one column, and then have the SQL thing put it out. And I was, at the time, making a column for every single contest and contestant. Big problem happened, though, is because this one had 800 contests, and some of them had 50 contestants because of the way they did it. So it was turning out to be 3,000 columns, which turns out these databases kind of get slow when you add 3,000 columns. They're not used to that number of columns. So I had to change that as well. But when I found that my indentation was incorrect and I just unindented that section, then it took about 3.6 seconds to do the same parsing. Moral of the story, make sure you look carefully at whatever you're trying to debug before you start saying, I know how to fix that, because this will be a really sexy way to fix it. ChatGPT even recommends it. Careful of that one. And then by doing that, I actually found the thing that I should have found to begin with. But in the other side of the story was, by making that mistake, I actually found or JSON. I learned something about DuckDB. Okay, that's the end of my little talk. Thanks. Question, yeah.
I was going to mention a couple other tools if you ever want to do it from the command line. One called JQ. You can use it to transform your JSON into any format you want on the fly. And YQ will do the same sort of stuff on YAML or CSV or even XML and a lot of other formats. So you can get into SQL pretty quickly that way as well.
Okay, JQ and YQ. Okay, any more questions or any comments?
Okay. Yeah, you're up. We need to get David on here. All right, our last speaker is going to take a little bit of setup, but it's David Neal, who is talking to us from Auckland, New Zealand, and he's going to talk to us about Python walks into a random bar. This is a talk about random. So we're going to get this set up. It might take a minute or two.
Yes.
OBS keeps crashing because Wayland sucks.
This one? Other way. Yes, 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 got it.
So,
Just need to make sure.
oh, I'll message him to let him know that he's on because he probably has no idea. I mean, I told him that he was next. Is this the same link as before, or
Yes,
yes?
yes. So you're not seeing me?
We see you.
Oh, I mean, I was
You
just want to make
see
sure.
the audio's not coming through though.
Okay.
So your audio output isn't.
All right.
Oh, but we don't have audio coming
Mic,
out of
this,
out of here yet.
this.
We'll have to wait till
I don't
David
know.
joins us.
Okay.
Let me see if I can get
Oh, that's good.
Oh, hey, you joined. Okay.
Cool. Let's see. And another.
So yeah. I don't hear him yet. And the chair coming out of
Now let's see if we can do this backwards.
I can see everybody.
Yes. Cool. We can hear. We can't see you, but
Jeremy, can you make that one up full screen?
I can try.
Or will it break?
Yes.
Yeah. I'm going to mute the other microphone.
Yep. I can hear you. I can see you. Good evening, everybody. Can you see my slides, Jeremy? Oh. Got it. Okay, so you can see the display and you can hear my voice. Excellent, excellent. Right, I've got a very slow repeat. I know what it is. No, it's more likely that I still had the YouTube playing. Yeah, these things are sent to try us. Okay, are we live now? Excellent. So a Python walks into a bar. The bartender says, "Don't you know, you can't drink here unless you first tell a joke." The snake hisses at him and says, "How many psychologists does it take to change a light bulb?" "I don't know," says the barkeep. "How many psychologists does it take to change a light bulb?" None, says the snake, but first the light bulb really has to want to change. Now, this poking fun at the psych community is amusing to me because I'm not really that kind of psychologist. My research area is a small corner of cognitive psychology, specifically how do adults best learn. This is ChatGPT or DALL-E's idea of how that little joke should be displayed. The subject of, while I'm quite good at the declining art of changing light bulbs, today's objective is to try illuminating a seldom lit package in the PSL called random. Thank you for setting up these meetings, David and Jeremy. All of us heard, in fact, Jeremy said a few moments ago, both of these guys and the other leaders of SDPi describe themselves as the speaker of last resort, meaning that if we don't volunteer a talk for these meetings, one of them will have to step into the breach. Have you ever wondered how they might do this? I mean, they wouldn't just draw straws, would they? You'd expect that they'd use Python, wouldn't you? Plus, you'd imagine that they'd have some fancy algorithm being pressed into service as well. Well, spoiler alert, here it is. Yeah, I got it wrong, didn't I? It wasn't David, it was Jeremy. Never mind. Okay, so random. The random library, part of the PSL, comes with Python normally, offers several alternate ways to play with sequences or collections in Python. So the examples we're going to be playing with, we're building the logic of some sort of a music machine or a music player to enable the user to program the music he or she would like to hear. Now you can see on the left the sort of music player that you'd expect me to be using. Then of course a bit more modern is the jukebox style. And this thing that looks a bit like the controls of the space shuttle is what they assure me young people use today. Now, anyone can write the code to run through the tracks in a playlist, right? So anyone like these, like the vinyl record on the left, anyone can just play from track 1 to track end. We want to be a little bit more complicated than that because we are Python people. So let's use the random library to play back 3 tracks selected at random. And let's hope that the computer will actually work for a change. Right. Okay. So here is a little piece of code which imports the top 5 songs or a list of top 5 songs by the Beach Boys, which we can see in the output. Okay, let's try going in the right order. There we go. Yeah, questionable music taste, I agree. 3 tracks are selected at random. If I select again, then you will see 3 more tracks. And if I select again, 3 more tracks. My computer knows it's supposed to be performing well, so of course it's not. Let's try again. Good. Right, we see the original list of names has been preserved. So the list of tracks, the titles of the tracks hasn't been changed at all. Even by the end of this routine. You can ignore the comma separate function. It's only there just to make things look nice. We're using the random.sample function. In case you are not a statistician, in other words, you've maintained a reasonable hold on your sanity, the letter N is shorthand identification representing the size of a population, whereas K is used to represent the size of a sample. In the likes of opinion surveys, or perhaps predicting where voters are going to go in the next week or two, the idea of a statistical sample is to analyze smaller groups of people or smaller volumes of data and extend observations from the sample towards the wider population. So in this case, the full playlist that we have available in our music machine is the population. The playlist size is only 5 for reasons of space, and our sample is K of 3. And here we can see in the random sample function call that we have indicated the size of our sample, K equals 3. In plain English, we're extracting a sample of 3 from a 5-member population. Another example application might be to select a sample of speakers from amongst the PUG's membership, Jeremy. The membership then would be a population. Perhaps we could utilize this algorithm to volunteer people as speakers for the November meeting, Jeremy. I'm not hearing him laugh, but I can't hear you guys. So, oh, there he is. See how helpful I am to you, Jeremy. In the next iteration of our MVP, of our wonderful project, our objective is to persuade the music machine to play back a set number of tracks selected at random. In other words, it chooses the playback for us. So, same data. In this case, when a track is played once, there may be no reason why it shouldn't be randomly selected again later. Conceivably, even immediately after it's finished playing, it could be selected again. So there's a subtle choice, a subtle difference between random choices, which is the function we're using here, and random sample, which was the function we were using earlier. And it's this business of replacement. So the technical term for this is chosen from the population with replacement. Notice once again, at the end of the routine, the original list of track names is retained. It's in the same sequence as it always has been. Now, in case you didn't study statistics, please be aware that interesting behavior can occur by sheer chance. Hey, random chance. For example, after shuffling the music tracks, there's a 1 in, 120 chance, so that's 0.83%, that the shuffled list will be in the same sequence as it was when the script started, even though you may think that such things should be random. It is 1 chance out of however many that has been randomly selected. So therefore, it is actually possible that there's no change. So we could be selecting elements at random. We could end up with exactly the same sequence of items on our playlist as the playlist itself by some random chance. MVP number 3. What we want to do this time, instead of a selection, we want to play every track. We just want to play them in a random sequence. So building on the previous, we only want to hear each track once until we've heard all of the tracks once. So no repetition until we've heard everything. This is known as shuffle. That's the functional term as opposed to me trying to dance. This code demonstrates that. Thank you very much, computer. It's given me the images out of order. Lovely. Okay. So the pertinent point there is that the entire playlist has been shuffled. The original playlist has also been mutated. So you have changed the original list. Right. I'm sorry. I think we have lost a slide somewhere along the line. There we go. Okay. You can see the original list has changed. Right. Now, the problem with using random is very much testing. A random sequence is not predictable. The technical word is stochastic, which is, in its purest definition, something of a guess, which is probably the way a lot of people look at statistics. When we are testing, we want things to be deterministic. That's the exact opposite. In other words, we want everything to be entirely predictable. So random offers us a function called seed. And the seed value means that we can set a particular sequence to repeat every time we run the code. In case you're wondering about the constant meaning, it is, of course, 42, the meaning of life, the universe, and everything. So the situation that's going to occur here is that when we run those first lines of code, 32 through 35, we will get a random selection. When we run the second set of code, lines 39 through 42, we will get a series of data which is repeatable. So on the left-hand side, you can see an original playlist, then exactly as we did before, a sample of 3 tracks, and then a second sample of 3 tracks. So we called the function twice, 2 different samples received. On the right-hand side, we're using seeded tracks, if I can use that term. So we use the seed of 42, and we say, give us a selection of 3, and we get that selection. 3 tracks, California Girls, Surfing USA, and blah, blah, blah. Then we do exactly the same thing again with the same seed, ask for another 3 random tracks, and they're not so much random as repeating. So the seed used twice allows us to generate the same sequences twice. If then at the bottom on the right-hand side, we go seed-free again, we end up with a selection of 3 random and quite different from the previous 2. So using a seed value means that you can predict the answer, which is very useful in testing. If you're doing a calculation and you want to be sure you've got the right answer, it's going to be very difficult to work out if part of your calculation is a random number, for example. And just a little stop press, Python version 3.13 has an extra little gadget for random. You can run it as if it's a macro. You can run it in the same way that you probably run pip if you're still using that program. Apologies about the great long prompts that I have on my terminal, but there we go. If we select who's going to be the leader of last resort, the speaker of last resort, we can choose from David, Diane, Drake, and Jeremy, and we can do it all from the command line. So there we go. Diane, you're up. I suspect she said something and I couldn't hear her, but I can imagine what it was. Yep. That's nice, isn't it? Now, one little thing that you may not have picked up because I didn't emphasize it is, first of all, to be able to use any of these, you need to import the random library, if that wasn't obvious to you. And the second thing is, I haven't talked to you about using random to generate numbers. I kind of figure that anyone who's a statistician or a mathematician who opens the random library is going to probably figure it out very quickly and doesn't need any help from me. Anyway, there we go, Jeremy. I've solved all your speaker problems for the rest of the year and possibly the rest of the century. Thanks, Diane. Yep. Oh, that sounds terrifying.
Okay. We have one more quick talk, and then we'll break. And David's going to talk to us about analyzing a laser beam. Is that right? All right. You're on HDMI, right? Yeah. Let me see. Oh, okay. Yeah, it should come up. Oh, it hasn't yet. Something's happening. It's probably coming. Might be this button here. No, just press this button. Duplicate. Okay. So whatever, it should show up on the right TV there. It hasn't yet. And this is the right HDMI, and it's not loose. Would you mind if I try the... Oh, you're good. I'm not going to touch it.
Yeah, I shouldn't touch it either. Okay. Thanks so much for having me. My name is David Ward. I'm going to talk to you today about analyzing a laser beam using the tools Python, JupyterLab, NumPy, and Matplotlib. I'm running the analysis right here in a Jupyter Lab. How many people in here have used JupyterLab before? All right, we got a few people. So I'm going to show you how I use JupyterLab to analyze this laser beam, and I've timed this presentation to end in 8 minutes, and if I'll take questions after that, and I have to go kind of fast, so I'm sorry I can't get into the details, but I'm going to show you some of the interesting parts of the presentation here. So right here in the Jupyter Lab, I show a picture of our lab setup, and what we have here is a laser beam that's coming in from this arm that's sticking out from the front of the page here, and it's hitting that scatter plate. And we have a little camera there. It's sitting on that post. It's taking a picture of that laser beam. And here's a picture of that little camera. It's a not very expensive camera, but it takes digital images. It's for scientific imaging, and maybe it's a couple $100, and it's a reasonably good performing camera. So I'm gonna in this Jupyter Lab, I'm gonna load the libraries we need, Matplotlib and NumPy, and I've got the widget there in this code, and that allows us to zoom and interactively play with any of the plots that are generated. We read in the beam image, and it's a TIFF file, which is a standard image file format that goes back many years. These cameras still use that file format. I read in the image, and then I display it, and here it is. Here's a laser beam profile, or an image of the laser beam captured by the camera. And you can see it's bright in the middle and dim on the edges. That's what I like to say about laser beams. And you can see that's true here. It's dark where the pixel values are 0, and it's bright where the pixel values are large. And this is just a very simple 8-bit image. So there's only 256 values per pixel. So in this demonstration, we will find some metrics. I'll show you the beam profile, that's the beam shape. We'll talk about the beam picoradiance in watts per centimeter squared and the beam diameter in centimeters. So first we'll find the center of the beam. I'll use the centroid function, and you can go look this up on the internet. It's a very simple function. Really all it is, this is in just one direction. It's just taking the image values, the pixel values, times their position with the x coordinate here, and summing them all together. And so that gives us the x coordinate, the centroid, and then you do the same for the y coordinate. And I do that here with the NumPy function. So like here you see me summing the beam image on one axis, and then I multiply it by its coordinates on the x-axis, and then compute the centroid in x and y. And then I print it out here. The centroid is located at 375, 246. And I could test that by coming back here and moving my cursor around, and you see the coordinates are displayed at the bottom there. So if I put my cursor there, that's about right where it says the centroid is, and I believe it. I believe it. So here I am now taking the beam image, and I slice it, and that colon there, you see it's in the square brackets. I'm going to slice, that's called a slice. I'm going to take all the values on that center line, and I'm going to plot in x and y. So I do that for x and y, and here's the beam profile. And it's what we would call a Gaussian beam, and that's what's produced by a simple collimator that produces that laser beam spot on that scatter plate. Okay, now we're going to use a ruler to get the pixel dimensions. So you might ask, well, how do you know how big a pixel is if you're going to compute like things like beam diameter? Well, you just put a ruler in front of the scatter plate, and you take a picture of it. And here I've plotted on this picture some points, and I put them on the markers on that ruler, so I know it's 3 inches from those 2 points. And I just move those little red dots around by just changing the coordinates here. And then I use those coordinates and I compute that distance in pixels, and then I compute the pixel size in centimeters, and I print it out here. The pixel size is 141.3 micrometers. That sounds about right. Okay, now I'm going to add the known laser power to calculate more metrics. So the power of the beam is a 500-watt laser. That's what that laser system is. And we can compute the number of watts in a single count. What's a count? One count is one of the least significant bit of a pixel. So I just do that by saying watts per count is power on the target divided by the sum of the beam image. It's very simple. You assume one count in the image is the same for almost all of the pixels, and it approximately is, and it comes out to 24.8 microwatts per count. Now I'll compute the picoradiance, or the mean picoradiance, and so I need to do this. If you see in these scatter plate images, these cross sections are quite noisy, and that can happen due to this thing called speckle. That's laser beams have constructive and destructive interference, and it'll cause those spikes and troughs in there. So I'm going to average some of the pixels together near the beam, and I do that once again with the slice operator, and I use that colon in there, and I take the center -2 and the center +3. That's 5 pixels. I take 5 pixels in the y and 5 pixels in the x, and I average them together, and then I get the average pixel near the center, and I multiply by the watts per count and divide by the pixel size in centimeters squared, and then the mean picoradiance near the center is 22.8 watts per centimeter squared. And I can tell you from experience, if you put your hand in front of that laser beam, it's going to hurt. So don't do that. 22.8 watts per centimeter squared, that's kind of bad. Always wear your laser goggles when you're in that room, by the way. You have to, that's a requirement, or you will get fired. So that's true. Okay, beam diameter calculation. beam diameter calculation. The last thing I'm going to calculate is beam diameter. So this is kind of an interesting operation with the NumPy tool, NumPy package. So I'm going to do a logic operation. Here's what I'm going to do. I'm going to take the beam image, and I'm going to use this conditional less than, and I'm going to take 13.7% of the average peak pixel near the center. And now that's what you'll find on this Wikipedia page for the 1/e squared diameter. At 13.5% of the peak, that's where you want to measure the diameter. So I'm going to take a little bit higher. I'm going to take all the pixels that are less than 13.7, and then I'm going to take the logical and of pixels that are greater than 13.3, which is a little bit below 13.5. And then I'm going to plot them. And there they are. So those are all the pixels that meet that criteria. Then I'm going to take those pixels and I'm going to measure their distance to the center. And I'm going to do that right here where I would say, take all those pixels, arg where is where those pixels are true. And then I'm subtracting the center. And then I calculate the distance that's of that vector. And then I'm going to plot them in a histogram. And here's that histogram. So you see all those pixels are about the same distance from that center. And I just did that to confirm, yes, they're all about the same distance from the center. I'm just going to average them all together. So I'll use the mean of the distance, then I'll multiply by the pixel size times 2 to get diameter, and I'll print that out. Beam diameter is calculated as 7.85 centimeters, which sounds about right. So there we go. There's my analysis of a laser beam. Any questions? Yeah, go ahead.
So the diameter is based on the power level you're looking for pixels between that 13.3 and 13.7.
That's correct. Yeah.
And is the 13.7 and 13.3 something like the one standard deviation or something?
It's 2 standard deviations. If you take if you take 1/e squared, you'll get 13.5. I think it's 13.51 or something like that, but yeah, percent. Yeah,
that's a pretty uniform. It looks like a very.
It came out very uniform. It is, laser beams can be of all different shapes, and my job is to analyze laser beams, by the way. And most laser beams I look at don't look like this beautiful picture here. Yeah, go ahead.
Does it have any sort of
Asymmetry or? This one does not have a lot. This one is in a lab setting, and so the beam doesn't go through very much atmosphere, but a lot of the laser beams I look at go through a lot of atmosphere, and when they do, they get very broken up. They will have multiple hot spots. They won't look circular or Gaussian at all quite often. But this is in a lab setting, and we use this laser for calibration. So we kind of want it to look like this.
Can you measure the circularity of? I mean, you showed it on the histogram that they're all within a range, but
yeah, I could locate if some are closer than others in certain areas, and absolutely could do that. I haven't done it, but yes. And I guess if I wanted to, I would. But
you don't care.
I guess
It looks good enough to you.
I think it looks pretty good, so I'm okay with it for now. But if I have a reason to do it, yes, the tool could easily handle that kind of computation. Any other questions or thoughts? Great. Thank you. Well, thank you so much. Oh, there is a question at the very top. Go ahead. Pretty much, yes. Typically, beam, and I showed power on target on here, that might be something you don't have available to you unless you have another instrument. So I happen to know what the power of this laser beam, because it is in a lab setting. But if you were trying to measure the laser beam with just a scatter plate out somewhere in the field, you might ask the question, well, I wonder how much power is in there, because you could have a picture of it, you wouldn't know what the power is. So there may be ways to get that information at the same time, but that's kind of a long topic. So I'll leave that for another day. Yeah, go ahead.
Is that little camera pretty good in terms of linearity and so forth? Is that one of their features?
Absolutely, it is. Yes, and those cameras, I've designed cameras myself, and they're very linear. Matter of fact, some of the equipment I've designed that does this type of thing have a very high linearity, less than 0.1% non-linearity, so that 99.9% linear, yes. Absolutely, yes. And in general, that you will see that's true. And as evidence of that, I mean, it's not easy to obtain, but the cameras in your cell phone, they're very good. They're very good. And it's because of these reasons. And so scientific cameras can even be better. Not too hard to believe that, right? So, okay, anything else? Great, thanks for your time. I appreciate it. Yeah, thanks for letting me present. Yeah.
No, that was great. Very cool. That wraps up the meetup pretty much. I want to thank the speakers and Qualcomm for having us, and Neo4j and JFrog for sponsoring us. And please sign up to be a speaker so that we can have great speakers for November, December. And remember, don't show up on the 4th Thursday, these next 2 months. You will be alone. All right. See you.
San Diego Python. San Diego Python.
Okay, cool.
It was the October.
October. Gotcha. Thank you.
Yeah.